Now, back before Christmas, we were learning about sound. And I know it's been a while. We lost track of that, all the baby and everything else that happened. But we're going to review all the things we learned. Do you remember that we were able to make like these toilet paper kazoos, and we made vibration sounds, and we had like little flute fingers on it, and we were getting the paper, the wax paper, to vibrate, and it made a noise. It made like a kazoo sound noise. We'd also done the coffee can vibrations and the pan, and we were seeing that vibrations turn into sound, very much like what Joe was doing with rubber bands earlier. And then we realized that our vocal cords, we learned that our vocal cords in our throats, they create this, just like that rubber band was vibrating, they vibrate too, and they produce sound. And when we move our mouths, we can change and manipulate those sounds.
Like an echo.
Well, what we're doing is we're shaping sound. That's what's really cool. We can shape the sound. We make the sounds with our vocal cords, like the band, and then we actually shape them, okay?
Like this one?
When we whisper, we're not making voice, but when we talk through our vocal cords, we're making a voice. Solomon.
Like when you go like this.
It vibrated the table.
Yeah.
Okay.
Look
Yeah.
at the box.
Listen to the sound. If I go flat, it creates the slap sound. If I go hollow, it changes the sound. Okay. And sometimes if you get it right, you'll actually hear the sound of air rushing out really fast, which is
Daddy,
also
wait.
vibrating.
Kind of like this.
And what's vibrating? What's vibrating when you do that? Your lips are vibrating and the air is vibrating. We also learned that inside our ear there are different components, and there's a canal that our outer ear funnels the vibrating air into, and then that hits a eardrum just like the kazoo, and when that vibrates it pushes on 3 little bones that go through a vacuum, and then it actually moves through something that has lots of water in it, because we know that vibrations move better through water than they do through air. And so it goes from the air through some bones to water and then out to our nerves, and that tells our brains what sounds we're hearing.
Yeah, and then it goes up there. And
No.
also...
No, that's just bone. That's just representing bone.
Joe!
It goes through these nerves to
Daddy!
your brain. Nerves.
Well, I
These
thought
nerves here to the brain. Okay.
it went that way to the other ear.
Nope. Not there. Then we had lots of fun. We made these telephones out of cans. And then we took that big coffee can. Remember the big one?
Yeah.
And we used that on one end, and it was like really loud. It was really cool. And that's because the small can was able to vibrate a little bit, and the big can was able to vibrate even more amplitude. That means it was able to vibrate further and create louder sound. And then we learned, we really checked out that when we listened through water, we were actually able to hear really, really well, and because water actually transfers vibrations better.
Yeah, but it was really cold.
It was cold, yes, it was cold. And then we also realized that through a vacuum, sound does not travel through, so in space it doesn't, because we watched some demonstration videos on how this works, since we didn't have our own vacuum thing, but we saw it on videos and how they did it, and
Fish?
it went quiet.
That's an ear. A fish ear.
Right, and fish also have ears, and they can hear in the water, and they can hear you if you're fishing, so we have to be really quiet when we fish. We also learned that because we have 2 ears, we're able to locate where sound is coming from, because 2 ears help us to
Can we hear thunder?
hear in stereo, and we can find where stuff is.
It's
And then
the
we were
ground.
able to see vibrations happen in a pan of water. When we were striking the pan of water, we could actually see sound waves move and bounce off the walls and return, and that was really neat. We could see actual echoes. Okay. We were able to see kind of what sound waves do with the slinky, and we were playing with the slinky, and it was bouncing back and forth. Remember that one?
Mm-hmm.
We'd let it go, and you'd see the compression move back and forth.
But we didn't do this one.
And this one, bouncing sound. We did a version of this bouncing sound in the room. I can't remember how exactly we were working on it, but we were playing with tubes and sound in the room, I think. Is that how we do it? I had something figured out we did. I can't remember now. And then we looked at the shapes of the flashlight. Remember, we were saying that if it was straight on, then the sound was the same. But if it was actually being hitting on an angle, then the sound was going to change, just like actually what our mouths are doing to the vocal cords. That's actually going to change the shape of sound.
But what about when you burp?
And so that means if it reflects... Well, what happened there when you just burped? What happened?
It went up like air went up out.
And the rushing air, column of air coming through your mouth vibrated. And you changed the shape of that sound as it worked its way through your throat. Partly your throat was vibrating too. Sound of a heartbeat.
Just because he talked about it being educational doesn't mean it's appropriate to continue to work.
Remember we talked about amplitude? That's how loud something is going to be. The more it can vibrate, not the faster, but the more movement it can have, the louder it gets. That's why that big can was louder than a small can, and that was really neat. Okay, and then we also played with the decibel meter, and we were listening to different sounds and how loud they were with the decibel meter on the phone. And we talked about that there's some decibels that are very dangerous, and if we're exposed to even not one, some of them that are not super loud, but for too long can give us damage, or for a short period of time, super loud things can be damaging. So we want to take care of our ears and put on ear protection. And sound is measured in something called decibels.
Hey, Daddy, I've done that. I blew like that.
We blew, I think I had one bottle we were able to blow on. And then we actually tapped on the glasses. Remember we've tapped on the glasses? And we had the different sounds going? Mm-hmm. And I did that with 2 types of glasses because for some reason we were getting some weird behaviors going on there with the sounds. And we had put away our china cabinet because we were trying to move, so we couldn't do any of the crystal. So Josiah's going to demonstrate blowing on the top. So inside this tube is air, and that air is vibrating up and down when he does that. Okay, all right, good. That's good. That's good. Rubber band guitar. We made a rubber band guitar last year, and we were able to hear those guitars strumming, and we were changing the strength of the elastic bands. We could get different sounds off of them. And Dad did a demonstration with his guitar on vibrations of the strings. Remember when I pulled my guitar out and we did all this?
Mm-hmm. Yeah.
And we were able to see the strings vibrating, and when I played it, I was able to shorten the string length, and it changed the pitch.
Is this high pitch?
And this frequency stuff is probably just a little older than you guys, so we're not going to go through all those details. And...
Is this high pitch?
oh yeah, did you know that some animals can hear sounds that we can't hear? The human ear can hear between...
a whistle.
20 and 20,000 hertz generally, and there it is too. There it is, 20 to 20. And animals like dogs can hear higher, up into 60,000 hertz, and dolphins can hear higher. And that's really neat. And
What about wheels?
we built the gramophone, and you see that in another video or a couple other videos, and how we were playing with that. And I hate to say it, it doesn't work that well, but it was a neat experiment to see how we could actually print sound down and save it and then replay it again later.